It's something we've all wondered about, but rarely do people take the time to research and answer. But don't worry, because in this episode, I'm going to answer the question, why is the sky blue? Alright, let me start by asking you a question. What color is the sun? If you said yellow, you are absolutely wrong. If you said orange, it's not that one either. If you said green, you may need to have your eyes checked. The sun is actually white. Just go outside and check for yourself. Wait, no, don't go outside and check for yourself. I'll just show you a picture. See? The sun is actually white. Since the sun is actually white, that means it produces photons of every color. You know Roy G. Biv, the colors of the rainbow. They're also the visible part of the electromagnetic spectrum. When you see all these colors at once, light appears white. Send that white light through a prism, and the different colors with their different wavelengths will be bent and separated, producing a rainbow. Red will always be at the top, with the bluer colors at the bottom. So what does this have to do with the sky being blue? Well, you see, not only does blue light bend more than the other colors as it passes through a prism, it is also scattered more as it passes through our atmosphere. This is because blue light has shorter wavelength than red, orange, yellow, and green light, so it is affected more by air molecules. This process by which light is scattered by particles such as air molecules is called Rayleigh scattering, and it is named after the British physicist Lord Rayleigh, who figured this out in the mid-1800s. So if you go outside and look towards the sun, you will see a blinding white light. That's not a good idea. Don't do that. But this is because all the colors of the spectrum are hitting your eyes at the same time. But some of those photons of blue light are not making it straight to your eyes. They're actually being affected by the oxygen and nitrogen molecules in the air and being scattered, which essentially means they are bouncing back and forth off of different molecules in the atmosphere. So if you go outside and look anywhere in the sky except for where the sun is, you will see a blue sky, because those photons of blue light have ricocheted off of a molecule for the last time before finally being sent to your eyeballs. It's pretty cool to think about all those photons of blue light just bouncing around overhead. Let's look at a demonstration of Rayleigh scattering that you can try at home. Take a clear pitcher or large glass and fill it with water. This pitcher of water will represent the sky. Now add just a tiny amount of milk and stir it in. The milk particles will represent oxygen and nitrogen molecules in the atmosphere. Take a flashlight, which represents the sun, and shine it through the water. As you can see, looking straight at the beam coming from the flashlight, the light looks white and maybe a little reddish orange. But as I move the flashlight, the rest of the water looks bluish. See the difference? It's the same reason the sky is blue. It's called Rayleigh scattering. Okay, but what about during sunrises and sunsets when the sky and even the sun appear to be more red? Well, you see, the same thing is happening, except now the sun is lower on the horizon and its light has passed through a thicker portion of the atmosphere. This causes more photons to be scattered, including some of those with a little bit longer wavelength, like yellow and green. So as the yellow, green, and blue light gets scattered away, you're left with mostly just red and orange. This is what gives us those incredible red and golden skies that make watching sunrises and sunsets so beautiful. So the next time you watch the sunset and see the beautiful assortment of colors in the sky, think about all those photons of different wavelengths bouncing around up there due to Rayleigh scattering. And be grateful you understand something people have wondered about for thousands of years. Because that's the cool thing about science. So stay curious, keep asking questions, and continue exploring the world around you, because you'll find that nature is even more beautiful when you understand the complex processes that produce the beauty. Thanks for watching.